It's a dream that many of us have been pursuing for decades across the industry and the academia. We have always aspired to build intelligent systems, computers and machines that can see like us, computers and machines that can hear, understand, and even feel the emotional context, and use these capabilities to interact and communicate with us. Well, it's been called human-computer interactions, human-machine interfaces, and many names. Today, I am really excited to share with you our efforts to make these experiences natural, intuitive, and immersive. Welcome to the era of perceptual computing, where the computers and machines can perceive the world and interact with human beings and each other. How do we accomplish that? How do we make this happen? Well, we take a deep look at the nature and copy from its playbook with pride. More precisely, we look at ourselves. We, the humans, have evolved to be very highly cognitive and interactive beings. We have developed a very nice set of sensors and actuators, visual, oral, tactile, etc., supported by a very highly capable brain. And we deploy this massive array of resources as we perceive the world, understand, and interact with each other. How about the computers and machines that we have developed? Well, first, let's take a look at the brain, where we have come a long way, especially thanks to the efforts at Intel. What you see here is the first commercial microprocessor, the Intel 4004, which was introduced to market in 1971. It had 2,300 transistors, working at a speed of 740 kilohertz. Humble beginnings, 40 years ago. This is an Intel Core microprocessor in today's computer. It has over 1 billion transistors, working at nearly 4 gigahertz. So in 40 years, slightly over 40 years, the brain inside the computer has gone from 2,300 transistors to over 1 billion transistors. It has gone from a speed of 740 kilohertz to close to 4 gigahertz. Well, to put things in context, this is the Homo sapiens brain. And this thing has about 100 billion neurons. Well, it's an average number, on an average. Some of us have some more and some less, but it's a pretty average number. The thing about these neurons are that they're rather slow devices. They respond in milliseconds or in less than a kilohertz. So I'm going to simplify this tremendously. Give or take, we are catching up with the nature as far as the brain inside the computers go. Okay? But we have forgot something. It's not just all about the brain. How about the senses and the perception? Well, that's a whole different story. So take visual perception as an example. With sophisticated 3D visual system, I'm showing a picture of human visual system here, and with stereo image capture and very highly parallel visual cortex in the brain, we perceive and see the world in 3 dimensions. And thanks to that, I can reach out, grab an object in 3-dimensional space, manipulate it, move it around, every time without making a mistake. It's critical to who we are and how we operate. Fossil records show that the nature experimented with biological systems with binocular vision about 300 million years ago, during the Carboniferous era. And all indications are that that was a home run in the evolutionary process. Binocular vision was a critical attribute of the earliest mammals, and it's widely believed to be the fundamental reason behind the success of this evolutionary group. So in contrast, here I'm showing the computing devices of today. They are simply one-eyed monsters, or the cyclops of the Greek mythology. With rudimentary 2-dimensional vision, they see a flat projection of the rich 3-dimensional world, and they discard a wealth of visual information in the process. you cannot have natural interactions with such rudimentary visual capabilities. Okay, so that's about the visual system. The same situation applies to other perceptual sensors. For example, the ear and the hearing process. Okay, so we forgot to add this capability and learn from the nature and develop interactive systems. We are changing that with perceptual computing. So we are focused on adding human-like senses to the computing devices, the eyes, the ears, voice, touch, so that they will be able to see, hear, understand like us. And with that, they would be able to interact with us. So I would like to show some demonstrations of some interactive, cool experiences that can be built with this technology. What you see on the screen, if I can go to the demo screen, please. So here you see Portal 2. Those of you who have played Portal 2, you know it's a hugely popular first-person puzzle game from Valve, right? You're supposed to play that with a keyboard. Here you see a special version of it enabled by Intel Perceptual Computing Technology in collaboration with our partners at 6 Sense. So as I get close, the system immediately recognizes my hand and associates my hand with this portal gun, which I can move around in the 3-dimensional space, as you can see. With a simple grabbing gesture, I can pick up the cube. Okay? And then I can move that cube in the 3-dimensional space. Left, right, up, down. I can even rotate it around with 6 degrees of freedom. And in this episode of the game, I'm supposed to put it inside the pedestal. Well, let me try. Well, obviously I cannot, I'm hitting the wall. So let's just go inside through this hole, align it over there on the pedestal, and drop it. Okay, so now, thank you. So those of you who have played Portal 2, if I want to, you'd know that if I wanted to do this routine with the keyboard, I would have to wish I had 20 fingers. So, that experience was natural and intuitive for me. I was using my natural resources. There was no keyboard, mouse, controller. It felt intuitive because I was manipulating the cube as I would in the real world. It felt immersive because I felt I was part of the content. I was part of the virtual world, and the boundary between the virtual world and the real world was starting to blur. Let me show you another demo. So here, if I can see on the screen, you see a treasure cave, an applet that our team built. You see this cobra fountain that's spewing gold coins. And I'd like to go and get some. So let me go in there. And see if I can collect some of those coins. Can I play with it? Can I move my fingers, throw them around? So that level of interaction where I can go in and play with virtual objects without having to move keyboard and the mouse is phenomenal. So this was made possible by the 3-dimensional image capture device based on soft kinetic technology and software that can recognize fine-grained 10-finger articulations in the 3D space. We have recently released the Intel Perceptual Computing Software Developer Kit that includes this close-range finger detection algorithm alongside the 3D camera, but also speech recognition and text-to-speech technology. It includes face recognition analysis and tracking technology. It also includes 2D and 3D object tracking technology. Okay, so and a set of APIs or application programming interfaces for all the developers out there to develop wonderful interactive applications based on it. So I'd like to show you just one more demo. It's tempting, we're running out of time, but I'd like to show you just one more. So here you can see me, and as I do this demo, I would feel really powerful, and you'd see why. So I've created the solar system with a simple gestures of my hand. And you can see I can make it smaller, I can make it bigger, many times. So it's just the beginning. And we have seen tremendous amount of traction with the developers. They're all developing very exciting application concepts with it. You'll see it in the market. The computing devices that you know today are going to be transformed with perceptual computing. when you add interactive capabilities to the computing devices. It's going to be a fascinating ride. I can hardly wait. How about you? Thank you.